Hello all. In this lecture we'll see about data types and variables in C. So this is the outline of this lecture. So we'll mainly see what are data types. Then we'll see some basic data types, that is integer and floating point data types. Then we'll see enumerated types, void, derived, and also we'll see what are variables and how to define variables, how to initialize these variables. So we'll not be going through this enumerated, void, and derived now. We will see in later lectures. So we will be mainly focusing on this basic data types. So we'll see what is a data type. So it is actually a system used for declaring variables or functions of different types. So when you have written these algorithms, you have already set read two values when you want to find the biggest among two numbers. So first is you have to read two numbers. So when it comes to C, we have to specify the data type or what is that type of number that should be read. Whether it is an integer number that should be read, or whether it should be a floating point number, or you can call it as a decimal number. So what type of number we want to input. So that should be specified. So in order to specify that, we need to declare those variables. There you have mentioned that read number 1 and number 2. Now here, when you write C programs, you have to specify number 1 and number 2 are variables. So what type of variable is it? Whether you are going to read integer variable or whether it is floating point variable. And similarly, when you learn functions, you will be seeing functions in later lectures. So for that also you need to specify the data type of that function. So it is a type of variable. The type of variable determines how much space it occupies in storage and what type of data is stored. So data type it is of a variable will determine how much space it occupies in storage. That is, we have already seen when you write programs and all, everything should be brought into memory or main memory. That is your RAM or primary memory. You have to store all those things. So when you write assembly code and all, you will specify the correct address location. In that storage, there will be some address locations and all. So here we will not be specifying that address location directly. Instead, we will be specifying using some variable. And we will say that this is an integer variable or integer number. So if it's an integer number, then that should be stored in the memory. So we have to allocate this much amount of space for that storage. So that is determined by the data type. So if we say integer, we may the compiler may give 2 bytes for it, or some compilers will give 4 bytes. You know what is a byte? So 1 byte it is equal to 8 bits, and if it is 2 bytes there will be 16 bits. That is that much information you can store. If it is 4 bytes, you can store 32 bits of information. So such lengthy numbers can be stored in when you have longer storage sections. So and also we will specify what type of data. So if it is whether it is integer or if it is floating point numbers like that, fraction numbers. Well, floating point means fractional numbers. So we will see the basic data types and enumerated data types are there. Then void type is there, and also derived data types are there. We will be studying only about this basic types at present. Later we will be seeing all these data types. So we will concentrate on basic types in this lecture. So mainly data types are divided like this: basic, then derived, enumeration, and void. Enumerated data type and void data type. So these are the basic data types, that is integer, character, float and double are considered to be basic data types. Then we have derived data type, we have array, pointer, structure, union. So we will see all this later lectures and all. And then enumerated data type is there, we have enum. Then void data type is there, it is specified using void. So int, char, float, double are the basic data types. So in this lecture we will see only about this basic data type. So basic types can be divided into arithmetic data types. So it can be further classified into integer types and floating point types. So mainly basic data types are arithmetic types, and in arithmetic types we have integer types and floating point types. Integer types means it can take only integer values like 25, 35, like that. Floating point values, floating point types means it can take a decimal part like 25.73, like that. If you want to have decimal or fractional part also, we have to specify using floating point types. So for a particular operating system, if you take a particular operating system, if you take a particular operating system, that if it is a 32-bit OS, this will be the memory that will be allocated. It varies, it depends on the system you are using. So if it is a 32-bit OS, the data type for character, the size will be allocated will be 1 byte. So if you declare some variable as character, only 1 byte of memory will be allocated for that, and the range of values is minus 128 to 127. So how this is got is 1 byte means 8 bits. So 2 raised to 8. So 2 raised to 8 is 128, and 2 raised to 8 minus 1 is 127. So it is, the range is from minus 2 raised to 8 to 2 raised to 8 minus 1. Then in character itself we can specify a signed character. Signed character, it also takes 1 byte, so it allocates 1 byte of memory, and the range is same, minus 128 to 127. Then there is unsigned char. So here 1 byte of memory will be allocated. Here unsigned means there won't be any sign, so only positive numbers can be taken. So the range is from 0 to 2 raised to 8, 2 raised to 9 minus 1. Okay, just a minute. So it is 2 raised to 9 minus 1. So it is 255. So it takes 0 to 1 byte. It is okay. Then we have another integer type. Next is int type. So integer numbers. So for 32-bit OS, it will be 2 bytes of memory will be allocated, and the range of values will be minus 32,768 to 32,767. So it is actually 2 raised to 16. So it is minus 2 raised to 16 to 2 raised to 16 minus 1. Then you can specify a signed in. The range of it will be 2 bytes, and the range will be same. And if you want to have only positive numbers, integer numbers, then you can specify using unsigned int. So it takes 2 bytes, and the range will be from 0 to 65,535. Then in integer itself we can specify short int. It takes 2 bytes and the range is the same. And signed short int is there. It also allocates 2 bytes and the range will be like this. Then there will be unsigned short int. It is 2 bytes and the range is specified like this, 0 to 65,535. And long int is there. If you want to specify a bit longer number, then you have to use long int. Then the range memory size allocated will be 4 bytes, and the range it is like this. So this amount, this much value can be stored. If you want to store a very huge number, then you can use this long int. And there is signed long int, the same range, and unsigned long int is there. Then the range will be from 0 to this much amount. Okay, so these are the integer types. Then we have floating point types, and these are all floating point data types. And first floating point is float itself, and the storage size is 4 bytes, and the range of value it is like this. That is, precision is 6 decimal places. And we can store floating. If you want to have a much lengthier number, then you can use double, which is of 8 bytes. So 8 bytes will be allocated, and the range will be from this to this, and 15 decimal places will be allocated. Then we have long double also, that is 10 bytes will be allocated, and the range is from this. So 19 decimal places will be the precision. So these are the various data types that will be used in system. So we can check the size of our system using a program. I will show a program. So we have already seen this hello world program. So you know this hello world, and we have specified this preprocessor directive. So try to do this program. Okay. Now I'll specify. We'll check the size of the system. So I have included the preprocessor directive hash include stdio.h, then preprocessor command another preprocessor I have include limits.h. You need not worry about all these things now. Then int main, it is the same as this previous program itself. Then we have open braces and the closing braces there. And between these statements, we will be in between these braces, we'll be writing some statements. So this is a printf statement, storage size for int percentage %d, and you are specifying the size of int. So size of operator is there. So we'll see the size of operator in later lectures. And this is an operator just to show how much size is allocated. You need not worry about this program. Actually, we will see the size of int character and unsigned int and float and double. So how many bytes are allocated? We can simply run this program and see. So if we see this, so for int, so in this system for int it is 4 bytes will be allocated, and for character it is 1 bytes. So it is actually a 64-bit system. So that's why 4 bytes is there. Unsigned int it is 4 bytes, and float it is 4, and double it is 8 bytes, like that. Now if you want, you can include a long double. You can make it long double. Okay, and I'll compile it. You can see that for long double it is 16 bytes is allocated instead of what I have written in the slide. It is different. So it depends on the, I have mentioned here it is 32-bit operating system, but here in 32-bit operating system only 10 bytes will be allocated. So this is 64-bit operating system. That's why you have this 16 bytes allocated. So similarly, you can check for any other thing, whatever you have mentioned. You can simply specify using this size of operator. You have to specify size of, and inside bracket you can check the different things. Okay. We need not worry about this program. We will see that later. So this is just to show how much size is there in our system. So you can try this program in your and check in your system also. Then derived data types. So second data type is derived data types. Right? In that we have pointer types. We will study about this pointer types later. Then array types are there, structure types are there, union types are there, and function types are there. So we will see all these derived data types later in later sections. Need not worry about. We will not study all these things now. Then we have enumerated data type also. In enumerated, these are actually arithmetic data types, and it is used to define variables that can only assign a certain discrete integer values throughout the program. Okay. Then we have void data type, and void data indicates that no value is available. Void indicates that no value is available. It is mainly used in specify the type of functions which returns nothing. So when we study functions, we will see this void data type. Next is an important topic. So what are variables and how to define and declare these variables? All these things will be covered. So a variable, it is a name given to a storage location that our program can manipulate. So I have already mentioned we require some variables to store this information. So when you want to read two numbers, those two numbers, number 1 and number 2, are called variables. So those actually in C programs, what we have to do is we have to give some name to those storage locations. So for that, for our convenience, we will be using this some names for that variables. So it is a name given to a particular storage location, and we can use that storage locations by using this variable names. So it is used to store data, and value can be changed and it can be reused many times. So value inside a variable can be changed and it can be reused many times. The variable can be used throughout the program, and it is a way to represent memory location through symbol. So we cannot directly specify the memory location. So actually there are addresses for each memory location. So if you see, if you have some bytes of memory, that means there will be a particular address location like 5000. So those are integer values: 5000, 5002, 5004. So similarly, there are different address locations will be there. So if you want to address a 5000 address location, instead of specifying the address, we use a name to specify it. So we will be giving some variable name like number or A, B, C, like that. We will be giving some names for that. So those will be actually the storage locations. So each variable in C has a specific type also. We have already seen what are data types. So each variable should have that data type also. So this type specifies which determines the size and layout of the variable's memory. So how much size that variable is and how much memory is allocated for that variable. And it also specifies a range of values that can be stored within that memory. So we have already seen, if it is integer, it takes 2 bytes, or if it is 64 bits, it will be 4 bytes. So it specifies a range of values. If it is 2 bytes, it means you can take from this range to this range, like minus 32,768 to plus 32,767. So that is a range of values also is indicated by the variable and type of that variable. And also it specifies a set of operations that can be applied to the variable. So for each variable we can have some various type of operations. We may be able to add two variables. So if it is integer, we can simply add two variables. Or floating point number also, we can add two variables. If it is floating point type also, then we can add those two variables. So it specifies a set of operations that can be applied to the variable. And there are rules for defining variables. So when we studied identifiers, we have seen some rules. In the previous lecture, we have already seen how to name some identifier. Similarly, in variables also, we have some rules for defining these variables. So a variable can have alphabets, digits, and underscore. It's similar. It's the same thing that we have used when we specified that identifier. So identifier are actually to use to identify variables and functions. The same rules are applicable. So variable is a type of identifier. So function is another type of identifier. So the same rules of identifier are applicable here also. So their identifier can have only alphabets, digits, and underscore. Like that, variable can have only alphabets, digits, and underscore. And a variable name can start only with alphabet and underscore only. So we have already seen in the identifier. And it can't start with a digit. No white space is allowed within the variable name. So we have already seen. Then a variable name must not be any reserved word or keyword like int, float. So we have already seen 32 keywords. So those keywords should not be used as variable names. So these are the basic variable types that we'll be using throughout the programs: char, then int, then float, and double. Then there is void. We won't be using this for declaring variables. Mainly we'll be using it to declare functions and all, return type of functions and all. So variable definition means it tells the compiler where and how much storage to create for the variable. So when we define a variable, it tells the compiler, the C compiler, to store tells the compiler where and how much storage to create for that variable. So where should be the storage location and how much space should be allocated for that variable. So a variable definition specifies a data type and contains a list of one or more variables. So we'll see this is a thing. So variable definition is like this: type, variable name. So we have to specify the type. Type means the data types we have seen, and variable underscore name we can replace with any names. It can be A, B, C, or underscore 1, 2, 3. Like that, you can use any names. All the things that we have followed in identifiers is applicable for variables also. So type must be a valid C data type including char, int, float, double, bool. Bool is also there, or any user defined object. So we won't be using this bool and all. So those who want, you can refer this bool and all. So we will be mainly using char, int, float and double. Then variable name consists of an identifier name. So it can be any identifier name. It can be ABC or a number one, number two, like that. It can be anything. So if you want to declare multiple variables in a single statement of the same type, then you can use this definition. Type variable 1 underscore name, comma, variable 2 underscore name. You can replace with variable 1 underscore name with any names, any valid names. This also can be replaced by any identifier names. And it should end with a semicolon. So the semicolon is important. So this is the way you can use this int number. So this means number is an integer type. Number is a variable name and it is of type integer. So if it is 32-bit OS, then 2 bytes of memory will be allocated for number, and the range of value it is like minus 32 768 to plus 32 767. So those range of values can be given to this number, and it is 2 bytes of memory will be allocated for this integer type. Int I comma j comma k. This means we have declared two variables I, j and k. So these are three variables. I, j, k are three variables, and all these are of integer type. Integer type. So 2 bytes will be allocated for I, 2 bytes for j, and 2 bytes for k. If it is 64, then it will be 4 bytes for 4. Then char c comma ch. Now we have declared char. So c is a character data type and ch is another character data type. Then float f comma salary. So we have declared two variables, f and salary, of float data type. Then double d. So double d means 8 or 10 bytes will be 8 bytes of memory will be allocated for this double. Then we can initialize this variables also. While we declare this variable, while we define this variable, we can initialize this variables if we want to give some values, initial values. So in some algorithms, when you have written, you will be initializing the sum value to 0. So if you want to initialize such kind of values or counter equal to 0, when you wrote algorithms, you have seen that initialization is needed. So initialization is also possible while we define these variables. So variable initialization is like this: type variable name equal to, we have to give some value, colon. So this means d is initialized to 3. So we are initializing this. So 3 values assigned to d. So this means d is of integer type. So 2 bytes or 4 bytes of memory will be allocated for d, and in that 4 bytes or 2 bytes of memory, this value 3 will be stored. So there will be some address location, maybe at 5000 to 5004. So there will be 4 bytes of memory, and those 4 bytes, in that 4 bytes we will be storing this 3 value in binary format or any other format. Then f. So f is another integer type, and we are initializing it to 5. So 5 value will be stored in some memory location. Then another type, second type is char type. So char x is of character type, and when you initialize this character, so if you want to assign a character value, it should be included in single quotes. So this ASCII value of this SX will be stored in X. So ASCII value, we'll see about ASCII value in later sessions. Now you need not worry. ASCII is American standard for code information interchange. So it is actually for each variable or character, there is some code that will be there. For a, small letter a, it will be some value. For capital letter a, it will be some other value. Like that, there are some values that will be assigned. So that ASCII value for x, it may be some value like 127 or 117, or some values will be there. So that value will be assigned to x. So you have to include in single quotes. Then we are declaring a sum and we are initializing it to zero point 0.0. Since it is float, it should have a fractional part also. So that's all about variables. Thank you.